So this video is about Cavalieri's principle and the volume of composite figures. What is the volume of the composite figure? Now, so this figure is made up of two separate shapes. Can you see that it's made up of a cylinder and a cone? Okay, it's like a cone sitting on top of a can. So if I want to find the total volume, all I need to do is find the volume of the cylinder and find the volume of the cone and just add them together, and that should be the total volume. So let's do that. Now remember, the volume of a cylinder is area of the base times the height. On the other hand, the volume of a cone is 1/3 the area of the base times the height. So those are the formulas to keep in mind. So for the cylinder, okay, we're going to have the area of the base and then the height. Okay, let's do the area of the base first. Well, the base is a circle, and I see the diameter is 12, so that means that the radius is 6. So if I want to find the area of the circle, area of the base, I'm thinking pi r squared, because that's the area of a circle. So if r is 6, squared, that's 36, so that's 36 pi. So that's the area of the base, is 36 pi. Are you with me so far? Does that make sense? Hello? Can you hear me? Okay. Well, for some reason I can barely hear you, but so if you have a question, make sure you shout really loud and I'll stop. Okay. So anyway, so area of the base times the height. Well, the height of the cylinder is 11. Okay, so I got the 11 right there. Now let's go ahead and do the cone. So for the cone, again, I need the area of the base, but I already found it. So when I do 1/3 and I do the area of the base, okay, again it's 36 pi. Alright, now it's time for the height. So the height, well, notice that the total distance is 20. But the cylinder was 11. So if the cylinder is 11 and the total height is 20, how tall is the cone? How tall is the cone? Alright, I hope you said 9. I can't really hear you, but alright, well, no, you subtract. Alright, the total is 20. If part of it is 11, 20 minus 11 will tell you the rest of it. Alright, these have to add up to 20. Okay, so the cone must be a height of 9. So I put in the 9. Okay. So this is an expression for the volume of everything. So I mean, I could simplify this out, or I could put the entire thing in my calculator. And that's what I'm going to do. Okay, so I'll go 36 pi times 11. Alright, and then plus 1/3 1/3, and again I have 36 pi, and then times 9. Okay, that gives me 504 pi. Okay, but they want a decimal and they want us to use 3.14. So that's what I'll do. I'm going to go 504. Oh yeah, calculator. So 504 times 3.14. So that gives me 1,582.56, which rounds to this. Okay. Which expression represents the volume of the composite figure? So it's pretty much just like the last one, except for they don't want us to work it all the way out. They want us just to set it up. When I look at this composite shape, I see a box and a pyramid. Alright, can you see the box and the pyramid?
Yep.
Okay, so if I add the volume of the box and the pyramid, that should give me the total volume. So that's what I'm going to do. The volume of the box is going to just be like length times width times height. So that's going to be super simple. The volume of the pyramid is going to be 1/3 the area of the base times the height. Okay, so for the box, the volume is just going to be, length times width times height. So that's going to be like 8 times 6 times 4. So there's the volume of the box. Does that make sense?
Yeah.
Alright, now the pyramid. I said it was going to be 1/3, and then it's going to be the area of the base. Okay, well the area of the base is 8 times 6. So it's going to be 1/3, 8 times 6. Okay, and then times the height. Let's see, I'll do purple. Now again, except for this time I'm going to be able to hear you. The total height of the shape is 10. The height of the box is 4. What's the height of the pyramid? 6. Okay, so this extra 6, that's the height. So I have 1/3, then the base is in green, and then the height. So this entire thing would be an expression for the volume of the composite shape. So compare that to option number 1. Now they sort of have the order of these reversed because it doesn't matter the order in which we add. But notice they have 1/3 8 times 6 times 6, and we have 1/3 8 times 6 times 6. Notice that they have 8 times 6 times 4, and we have 8 times 6 times 4. So it's the same. Okay, what is the volume of the frustum? Alright, the frustum is the lower part of this cone. Okay. Say that again.
What's a frustum?
Well, according to what they're saying right here, a frustum is formed when a plane parallel to a cone's base cuts off the upper portion. So if you start with a cone, okay, now if you took a big machete and you cut off the top of it, okay, so if I came along and I sliced off the top like this, and you took the top of the cone away, then can you see that you would be left with a shape like this?
Yeah.
Okay, this shape right here is the frustum. All right, it's what you get if you take the top of a cone away. And seeing that hopefully will help you understand the equation. Can you see that the frustum, this leftover part, is the result of starting with a whole cone? In fact, I'll just call it a big cone, minus the top. Okay, will you agree that if I took a cone and I took away the top, then that would give me the frustum? Does that make sense?
Yeah.
Okay, so that's how we're going to do the calculations. We're going to find the volume of a big cone, a full cone, and then we're going to subtract the top of it. That would be the same thing as slicing it off, subtracting it. So that's our strategy. Okay, so actually I'm going to do it over here though. Alright, so we're going to take the cone minus the top part of the cone. Both things are cones. Alright, the big cone is a cone, obviously. That's 1/3 area of the base times height. And then the little top part that we're taking off, that's a cone also. So that will also be 1/3 area of the base times the height. So just keep those formulas in mind. Okay, so for the big cone, I've got 1/3, and next comes the area of the base. Uh-oh, I lost my 1. Okay, well, the base of the big cone is a circle. The radius is 3. I'm thinking pi r squared for the area. That gives me 9 pi. So the area of the base is 9 pi. Does that make sense?
Yeah.
Okay, and then we need the height. It's area of the base times the height. The height of the big cone, alright, is like from here all the way to here. So we've separated it into two pieces, 6.8 and 6.4. So it's just a matter of adding those together, 6.8 plus 6.4. Okay, that will give you the whole height. 13.2. Okay. Okay, so that's 1/3 area of the base times the height. So that was the full cone, the big cone. Now I'm going to do the same thing with the little cone. So again, I'm going to need 1/3, and I'm going to need the area of the base, and I'm going to need the height. Okay, are you still there? I heard a sound. Alright, I'm going to assume that you're still there. I see your icon, even though I cannot hear you. The area of the base for the little cone. The little cone has this little circle. Alright?
I'm back.
You're back. I thought I heard the little sound.
Sorry, it keeps going on and off.
Okay, so the little base is a circle, pi r squared. The radius there is 1.5. So that's pi and then 1.5 squared. Okay, so 1.5, whoops, I don't know where that 6 came from. 1.5 squared is 2.25. So that's 2.25 pi. Okay, that's the area of the base for the small cone. So that goes here, 2.25 pi. All right, and then we need the height. Well, the height of the small cone is given as 6.4. Okay. So let's see. Do they want us to multiply it out? All right, looks like they want us to multiply it out. Okay. So look, let's do it. I'm noticing that their answers have pi in them. They're leaving pi as pi. So for that reason, when I put this in my calculator, I'm not going to put pi in. I'm going to leave pi out to the side. So in my calculator, I'm going to just do 1/3. And instead of doing 9 pi, I'm just going to do 9. And then 13.2. Okay, and I'm going to do minus 1/3. All right, 2.25 and 6.4. All right, I'm not putting pi in. So that gives me 34.8 and then pi.
I get 34.9.
Uh-oh. Okay, maybe I typed in something wrong. Well, I see the answer is supposed to be 34.8 pi. So maybe you did something wrong. Alright, the volume of this composite figure. When I look at this, I see a box and with a pyramid on top. So I'm going to do the box plus the pyramid. Alright, do you see that?
Yep.
Okay. The volume of the box is just going to be length times width times height. So that'll just be 7 times 3 times 4. Whoops, I didn't mean to put equals. I meant to put plus. Now remember, the formula for the volume of a pyramid is 1/3 area of the base times the height. Okay, so that's going to be 1/3. The area of the base is the rectangle. So that's going to be 3 times 7. So that's 21. And then the height. So let's use our trick one more time, like we did before. They've given us the total height is 12. The height of the box is 4. So how tall is the pyramid? That's close. That would make 11. 8. Okay, 8 plus 4 makes 12. So the height of the pyramid must be 8. Put it all together, and that should be the total volume of the composite shape. Okay, so that's 7 times 3 times 4 plus 1/3 times 21 times 8. That's 140. Okay, that's why the answer is 140 cubic inches. Okay, once again, we want the volume of the overall shape. It's a pyramid and another pyramid stuck together base to base. Okay, so for the total shape, we're just going to do pyramid plus pyramid. Okay. In each case, we have to be aware of the formula. So the volume of a pyramid is 1/3 area of the base times the height. 1/3 area of the base times the height. Okay, all I have to do is fill this in. Okay, well, both of them have the same base, and it's this rectangle. That's 2 times 7.5. That's 15. Okay, so in both cases, the area of the base is 15. Does that make sense? They both have the same height, just one's up and one's down, but they're both going to have a height of 6. Okay, so that's it. You know, I'm just going to calculate this out and be done. So I have 1/3, all right, times 15 times 6 plus 1/3 times 15 times 6. All right, that is 60. All right, so that's why the answer was 60 cubic units. Okay, now, when you have a shape inside of a shape and you want to find the space between them, instead of adding like we've been doing, you subtract. Okay, so that's what's happening now. We have a big cylinder and then we have a small cylinder on the inside, and we're trying to cut the small cylinder out and throw it away. So the story of this problem is we're going to start with a big cylinder, and then we're going to subtract the small cylinder from the inside. And that will leave the shell. Okay, so we have a shape inside of a shape. So we're going to subtract the big cylinder on the outside minus the small cylinder. In both cases, the volume of a cylinder is the area of the base times the height. So that's what I'm going to do. I'm going to do the area of the base times the height minus the area of the base times the height. For the big cylinder, I'm noticing that the diameter is 20. So what's the radius? If the diameter is 20, what's the radius? The radius is 10. Now this is a circle. So the area of the base, we're talking pi r squared. So that's going to be 100 pi. So the area of the base is 100 pi. The height is 21. Now the small cylinder. The small cylinder has a base that is a circle, but they just plain gave us the radius is 6, just straight out. So again, we're doing pi r squared, so that's 36 pi. So the area of the small base is 36 pi. Are you still with me? So we needed area of the base times the height. Well, the height of the small cylinder is the same as the height of the big cylinder, because it's just a hole going through the same length. So it's still 21. Okay. Now, looking at the answers, most of these answers are still written spread out. They don't have it multiplied down to a single number except for these. So I better stop now and check and see if any of these are my answer before I go multiplying it out in my calculator. So I look at the top one first. I see the 21, which I have, and I see the pi, which I have, and I see the 10 squared, which I have. So that looks good so far. And then I look at the second one, and I see 21, yep. I see the pi, yep. And I see the 6 squared. Well, yeah, that's my 36. So that is an acceptable answer. But there's more. If I multiply 100 times 21, that makes 2,100 pi. So far, this is looking good. Now, if I do 36 times 21, oh, look at that. I get 756. Okay, which is what they have. So there's another form of the answer. Okay, if I put these together, I would have to subtract 2,100 minus 756. So 2,100 minus 756. That's 1,344. So this is the same thing as 1,344 pi. Well, that's not what they have here. So that's why this one is wrong. And here I see the 1,344, but there's no pi. So that's why that one's wrong. Okay, so there are two correct answers, and these are the ones.